Hello, and thank you for coming to my presentation on scanning electron microscopy validation analysis. Before we actually go into the validation study that I chose, it's important to understand what exactly it is we are validating. To start off, so what is SEM EDX? SEM EDX stands for scanning electron microscopy with energy dispersive X-ray spectroscopy. So it's scanning electron microscopy, but coupled with energy dispersive X-ray spectroscopy. It's used to view both surface morphology and elemental composition, since scanning electron microscopy on its own is only really good for viewing the surface morphology. With this, it reads X-rays and electrons in order to form images and analyze samples as according to Hussein. So how does SEM EDX work? According to this diagram here on the side in the presentation, basically it starts with primary electron beam shines down and excites the sample's inner shell electrons. By doing so, holes are formed and electrons with suitable energy levels are going to fall back and fill them. By doing so, different X-rays are going to be created depending on the specific element. So, for instance, silicon's going to have a different X-ray to be read rather than lithium. Now, as this happens, the collimator is going to collect the specific X-rays that the analyst is searching for by adjusting the collection angle. By adjusting this collection angle, you can look for different elements as well. In the end, the beryllium window, not the B window, the beryllium window, filters the X-rays to allow for smooth detection as stated by Lee, and this image also came from Lee's research in her article. Now, what types of samples can be analyzed by SEM EDX? They are typically biological, anthropogenic, or geological. Biological consists of those plant matter, cells, things that are naturally occurring. Anthropogenic in the forensic world can classify as things such as drugs, paint samples, and gunshot residue. With geological, it's your minerals and your soil samples. For the study that we're about to go into, anthropogenic samples are being distinguished from natural biological and geological samples. Beginning to review our study that was chosen, the purpose of the study chosen was to determine the effectiveness of SEM EDX and ICP-MS methods. The samples that were analyzed were particulate matter that was found on spider webs and deposited from surrounding air pollution. The goal, though, of the study was to compare SEM EDX mineralogical and geochemical composition results to the ICP-MS results in order to determine if SEM EDX is a valid or equal method of analysis for particulate matter, according to Bartz. Bartz is the one that wrote the study that we are about to review. So some information about the study that I chose to review. They tested in many different samples in Glogau, Poland, near the copper smelter. They specifically were testing for particulate matter deposited on spider webs to see if spider webs were a good method of collecting particulate matter data. In doing so, they chose to analyze two different types of spiders native to the area, such as the funnel web spider, which is depicted right here on this slide. They reviewed 13 sites surrounding the copper smelter in Glogau, Poland, over a period of 4 months. I believe the period it was from around, I believe it was May all the way up until September. So in doing so, when they collected these samples, they took the spiderweb samples and they put them on a sterilized petri dish, being very careful not to fold them, as that would have complicated the data and provided inaccurate results. When taking the spiderweb samples, they applied it to a slide that had been prepped with double-sided sticky carbon tape. For the SEM EDX analysis, the analysts provided 14 kilovolts and a high vacuum mode, with 120 seconds of capture time on low magnification in order for Bartz to gather the results that they used to compare them to ICP-MS results that they were also using in order to see which one is more effective or if SEM EDX is at all effective with analyzing the particulate matter. Now for the study results, they were looking for chemical compositions that were different from the local minerals. So they did take control samples of the surrounding areas in order to get a good read of what are the natural occurring elements and minerals and what are the anthropogenics. Right here is depicted some of the images of particle sizes and geological composition that was collected by the SEM EDX analysis of the particulate matter. It was determined in the analysis is that SEM EDX is a less invasive and a less expensive mode than ICP-MS at the very least. Now, when it was actually compared to the results provided by inductively coupled plasma mass spectrometry, or ICP-MS, SEM EDX results were of a comparable standard. That's what Bartz managed to discover in doing this study. Now, my personal evaluation of this validation study, I thought that Bartz did a very good job sampling, and he used very strong testing strategies, taking from multiple sites over a large period of time. They even observed the spider activity, so that way only new web was collected and not dusty old samples. He also had a very clear goal for comparison with suitable controls, so collecting from minerals around the area. Very smart, I thought, but along with really aiming for, is SEM EDX effective, but also can we get the results that we're actually looking for of, is this copper smelter polluting the air and affecting the general air quality. Some possible improvements that I personally would have made on this validation study is I would have provided more background information on the ICP-MS in the reporting. And when I was reading through the study, there wasn't as much information on what ICP-MS was and what they did for the ICP-MS testing. It was more focused on the SEM EDX. I also would have chosen another testing site as well for more variety, because the test did prove that it works for testing for particulate matter or air pollution around a copper smelter, but what about a coal plantation? So I would have tested another area with a possible pollutant in order to see if this is just an isolated occasion for copper smelters. Also, I thought that some more emphasis was needed on how the two instruments' results compared. The only real comparison that was provided in between the two of them was these graphs that are presented on this slide right here. And as you can see through these graphs, they do show that SEM EDX and the ICP data create a very similar correlation line, and when combined, so it does help to prove that SEM EDX is a comparable or a viable method for testing for particulate matter. These are my references that I use throughout this presentation. Thank you for your attention.